For any definite integrals, questions that has got limits, as long as you have limits appearing, such as integration of 1 to 3, for example, as long as the question didn't say that I need exact values, please use the graphing calculator to get the numbers. There is no need to integrate. You will not be rewarded for any marks. Look up exactly for whether they want exact numbers. So where to get these numbers? When you are on your main screen, you could press alpha window, and there is this integration at number 4. Okay, so alpha window, select number 4, you get integration. I think from here, it's pretty intuitive. You input the numbers and you input your values of x. Okay, then they will give you a number straight away. So there's no need to integrate. Okay, only for terms with definite integrals with limits. And I also need you to know this number is the same even if you change the x to a y. So sometimes in your question, you are integrating y. But doesn't matter, you key to the graphing calculator as x values. It will give you the same number. Okay, so don't need to worry if your integration is with y, you're still going to key in as x, okay, to get the numbers. Okay, so we go through now with the problem on trying to get the areas. I've got this curve C. Let's recall how we get conic shape first. Let's sketch this curve C. What kind of graph are we looking at first? Let me remind you on your conics. If you see positive x squared and positive y squared both appearing, this is the equation for an ellipse. Ellipse. Can we change to the general ellipse equation? So for the left-hand side, I will get x squared over 3. We don't change that. For the y values, I have got to complete the square. Y squared minus 2y, we complete the square, minus 1 squared. Let me shift certain terms to the right-hand side. We get 1. And to make it completely into the form of a general structure, can I present it this way? Over root 3 square. So I wrote the powers wrongly, should be a square. The other term, I represent it as a over 1 square is 1. Okay, so what are the features of my ellipse? Where is that center? Center is when you let the numerators to be 0. I will get a 0, 1. You read off the denominators as your width and height of your ellipse. So width is root 3. My height is 1 unit. Okay, let's draw in the graph together. Help me get a big set of axes to be drawn. Okay, we draw in our ellipse. This is y, this is x. My center is at 0, 1. So can we label roughly where is 0, 1? This is a position of 0, 1. The y value is at 1. My height is 1 unit. Let me indicate that first. So you'll get the lowest point to be your origin. The highest point to be at 0, 2. The height is 1 unit. Okay, I mark out the vertex first. The width is root 3 units. So from the center, I could extend somewhere to the right such that we get this coordinate to be a root 3, 1. Okay, I want the width to be root 3 units. And I do the same on the left so that we get minus root 3 and 1. I'm marking out the 4 endpoints of the ellipse so that we can draw in the shape nicely. So we'll look something like this. And to complete the shape of the ellipse, after you have labeled all the vertices and the center, good for you to indicate the width and the height. So this is 1 unit, and the width here is your √3 units. This is your curve C. Okay, so nothing new for now. It's exactly the same as what we went through. Okay, so now can we try to get the area in part 2? I would like to get the area for region R that is bounded by your curve C. There is an axis minus √3 and an x-axis. So I want to remind you also that when you find any particular region, always make sure that you count the number of lines carefully. They told you that the region is bounded by C, vertical line and horizontal line. The number of lines is 3, which means that later after I shade the region, we should check the parameter to see that there's really these 3 lines appearing. Okay, so first one is curve C, which is this curve. Line x is minus 3 is here, minus √3 is here. This is x is minus √3. The x value on that coordinate is negative √3. Bounded to x-axis, so should be here. And we are looking at this 3. So if you see my red color lines, the region inside the red color lines is region R. And we should count that the region in the parameter really have those 3 lines. If we shade wrongly, then you're going to solve the area wrongly also. So this is the region that we want. So how do we find that area? It is obvious that the region is touching the x-axis. So if your shaded region touches the x-axis to find the area, we will use from x limits negative √3 to 0. The left end to the right end is minus √3 to 0 of the equation y dx. If we do with x-axis, always start with y dx. So what is your y? I am looking at this curve. What part of the curve is this? This is your lower half. We are not looking at the top part. I'm looking at the lower half of the curve. So if we plan through, I will need y to be the subject and you want to choose the negative root. Okay, so to get that, let's take this equation. I'm going to take from the second line. We want to rearrange our equation to make y the subject. So I will have y minus 1 square. I move the x terms to the right-hand side. We remove the square, hence getting a plus minus square root. So I have 1 plus minus square root. We are choosing negative root. You don't need to explain for them. You just choose the correct sign to put to your equation. So we will then put in our equation. We want lower half, we choose the negative sign. How to integrate this term? So look back at the question carefully. Find the area of R. They did not mention exact. And it is very common that they may not want you to get exact values, meaning for this, you use graphing calculator. Do not try to integrate the term. You may not be able to do so anyway. So just use the GC to evaluate. Because this is area, we then have squared units.